My mic is here plugged in, not on me, so remind me not to walk too far. If you see me walking, stop me. All right. So we finished up talking about unit tests, but there's going to be 2 unit test topics. The first one is testing like a simple collection, a simple class like the one we just did, where writing the tests are relatively simple. We will have another one. We will have another unit test topic when we finish talking about collections, so pretty soon. Just because writing unit tests for collections is quite tricky. Collection being like data structures. So it is quite tricky because they are very stateful and whatnot. So we will dedicate some time talking a little bit more about unit testing. But there is a nice systematic way we go about doing it that makes it a little easier for us. Anyways, data structure review. Let me make sure that's actually the right topic. Yeah, data structure review. So we built data structures in 161, right? You did like the country catalog and various other things. Why is this? Yeah, I don't care. Go away. What's going on here? There we go. Yeah, we're gonna build so I don't remember what we did last time. Was it like a course? What did we do in 161 when we built our first data structure? I can't remember. We just hijacked the list, basically.
Yeah, I think you were doing some cool stuff.
Yeah, I think it was like a course, or maybe it was like a contact list. I can't remember. But anyways, we built a friend class, right? And, oh, that's great. Just right out the window. We built a friend class, but the whole point of building the friend class was to have some way to manage my friends, all right? So we're going to build another class called the contact list that's really going to do all the managing for us. And this is going to be I really shouldn't call it a simple collection because it's actually going to be rather sophisticated. It's going to have a lot of general purpose usage. Okay, and also I'm pointing out here that as we go forward, I'm not going to show the comparison between the Python code and the Java code. I'm just going to show the Java code from now on. Cool? All right, so contact list. With the friend class complete, and we wrote the tests for it, although we didn't do it completely in lecture, they are available. We now can start making our contact list. That is just going to be a collection of friends. But we want to be able to like add things to it, remove things, search it, I don't know, a bunch of variety of things. Okay? We're going to build a contact list. I really hope they move. They moving? They're moving. Good. So what fields should this class have? So what's the data and what's the functionality? Well, this class itself is managing data. It's not really the data itself, it's managing the data. The friends class is the data. So the contact list is the collection, so it needs a way to keep track of those friends. And the only way we really know how so far in Java is with something, that array thing. It's not a list, it's like a list, but it's definitely not a list, and it can't do nearly as much as a list can. So we're going to use an array to store the friends, the individual friends. And we're also going to want to know how many friends are actually in that array. Because remember, an array, when we make an array, we need to know how big we want to make it, right? So I could start with an array. Like imagine I have a list and I want to add something to the list. I just append it. Great. But I can't really do that with arrays because I have to specify how big it's going to be, and its size can't change. I could do something like make an array of size 10. It's empty. So there's actually 0 friends in that array. It's got a capacity of 10, but there's actually no friends in there. So we'll keep track of an integer that'll let us know how many friends are actually in that contact list, how many we actually care about in that array. And that'll just be an integer. And the friend array is going to be an array of friends. So here's what the code would start to look like. This is the start of the class. In fact, I'm going to go over here. I'm going to do right click, new. So we have the friend, yeah, good. New contact list, there, a new class, great. And I'm going to copy all of this stuff over except the top one because we already got it. All right, and let's start at the top. Well, actually, let's not start at the top. I mean, public class contact list, that's just starting to make a class. We've got these two private static final ints that we'll come back to in one moment. And there's the two fields there. Private int size and private friend array called friends. Okay? Those are the two fields. The one is an array of friends. We can tell because it's got the type friend, and then we have the two square brackets next to it. That means it's an array, and its name is friends because I called it friends. And in size, well, that's going to keep track of like how many friends are actually currently in that array. Remember, this is just the declaration. We haven't created an integer. Sorry, we haven't stored an integer value there. There's no friend array actually created yet. These are just the variables being created. They're just being declared. Okay? And at the top, you'll notice two things here. Private static final int, private static final int. One's called default capacity, the other one's called not found. Not found's probably the more obvious one. Remember how last semester we used constants to give a meaning to a value? Well, we're going to do that again. We're going to have this special constant that is not found. Its value is just going to be -1, but we're going to want to use this special not found constant because it just gives more meaning to our code. Remember doing like a find? Do a linear search on this array for a particular friend and return its index. But what if it doesn't exist? Well, you return -1. Well, what does -1 really mean? Well, it's a special sentinel value, that's the word we use, a sentinel value to mean nothing was found. But seeing a random -1 there isn't that helpful, so we just give it a label, not found. When we see it used, it'll perhaps make more sense if you're still a little late. But we did the same thing in Python. But it's private, it's static, which means this value does not belong to an instance of this class. It's not a field. It's just a value that exists inside of this class. It's a constant. And then, in fact, there's the final keyword to mean, well, okay, it's a constant, it's an int, it's its type. Now, default capacity is another static constant. So this value is associated with the contact list class, not any instance of a contact list. It's not a field. It's not a property of an instance of a contact list. It's just some value that exists inside this class. It's shared amongst all instances of this class. And the purpose of this is, well, actually, let's see how I explain it in the text here. So, I have two constructors. Come on, scroll it nicely. All right. I have two constructors. Remember, arrays have a fixed size. So when I look at this constructor here, it's a constructor that takes one parameter. It has one parameter called initial capacity. And look at what this constructor is doing. It goes and assigns the field size to 0, because when you create a new contact list, how many friends are in it? None. So there's 0 there. Makes sense. And we create a new array. New friend, open square bracket. And the number we put in the square bracket is how big that array we're creating is. And here it's just going to take the value that's passed as an argument to the constructor to make an array of the specified value. So when I create a contact list, I can specify, make an array of size 100. There'll be 0 friends in it at the start, but it's like I've got this row of empty seats available to put friends in. I have to create the row of empty seats first. That's the array. And I specified it, I want it to be size 100. But sometimes, maybe I don't really have an idea of what I want that capacity to be. Right? I want another version of the constructor. And what's interesting here is, I'm going to rewrite the above constructor like this. There. So this is effectively what I'm doing. If I have 2 constructors, this is called overloading. I can have multiple functions with the exact same name as long as they have different parameter lists. So if I call the one that takes that has one argument, that creates the array of the specified size. If I don't specify a value when calling the constructor, it creates one based on some default capacity. And the default capacity is specified up here. You might, give me one sec. You might say, well, you could have hard-coded it as 10. You're right, but again, a programmer would see the 10 and they might go like, well, why? Where now, it really is the value 10 ultimately, but because it's a constant, it has a name, default capacity, it tells other programmers and yourself like, oh, it's just some arbitrary default size, whatever. You had a question.
You could explain that again. I just kind of blanked out for a moment.
Can you be more specific?
The part was talking about why you change the values on the default capacity.
How did I choose that value?
Why do you change it again?
Sorry.
I'm lost, sorry.
I'm not sure what you're asking, to be honest. We have a default capacity. It's just some constant.
Okay.
I could have just put a 10 in here, whatever. But I wanted to give it a name, so I made it a constant. So I can call the constructor with some argument, and it'll make an array of that size. If I call the constructor without the argument, it's going to make an array of some default size. That's what it's doing. So I can have 2 constructors. I can have as many functions with the exact same name as long as they have different parameter lists. As long as the number of parameters are different in their types and whatnot. Now, in reality, what I would do is I would write that. And all this means, this is what we call constructor chaining. This means, and it's kind of funny syntax if you don't know what it is, but I'll just tell you what it is. When I call this with the parenthesis, that means call this class's constructor. All right? So I'm calling the version of the constructor that takes one argument. And the argument I'm giving it is the default capacity. So if I ever call this constructor, it just actually delegates and calls this constructor, but with the specified value there. It's a little weird, but chances are if you're having a hard time wrapping your head around it, it's because you're working too hard to make it make sense. It really is as simple as that. This means call the constructor with the matching parameter list. Well, there's only one other one that takes one integer as an argument. So this constructor, if I ever call this constructor, it just automatically calls this one, but it automatically passes the default value here to here. Yeah?
So it's just like using the idea of writing a function instead of rewriting the same code, just kind of.
Yeah, we don't want to duplicate code. You could see the previous version was very duplicated code. right? That, I duplicated the code, right? It's basically the same. This, there's no duplication. It just delegates the work to this one by passing that value there. This is a common idea. Delegate the work. You might have multiple functions that all operate similarly. You really only define what it's doing once, and then all other versions just call that one with the various cases addressed. We'll see this more later in the semester. But this is an example of constructor chaining. Other questions about it? Any questions about those constants or the fields or anything we've seen so far in this class? Yeah.
So you said that this one would just be delegating to,
The constructor for this class. Yeah.
yeah, that takes the same type of parameter. So could you call, like, say you had another,
A third constructor?
yeah, that had the same
Yep.
type?
Yep. Okay, you couldn't have another constructor that takes one argument with the same type.
The same type, it can't be the same, like, can't be int, but with a different variable name?
It could be like no, it would have, if the types are the same, it's going to be ambiguous,
Okay.
even if the variable names are different.
Okay.
What matters really is the number and types and order of the parameters.
Okay.
Yeah. Any other questions? All right. So there we go. Things to notice. Imports. Well, there's actually no imports so far. There will be some later. Well, maybe there were some imports that we just didn't include. But we'll see where they come up later. To constants, to the fields being declared, and to constructors. Yeah. Size, second constructor, yeah. So here's the idea. This is a visualization of what we have. In fact, I'm going to go to lab 2. I can make a contact list now. Contact list. Do we want to specify default capacity, or like an initial capacity, or not? No. All right, cool. So when I do that, how big will the array be? 10. How do you know? There you go. How about now? How big would the array be? There you go. See, you get it. Very good. Great. But let's go with, I think in the picture I have 5. Yeah, let's go with 5, because why not? And I can run this. Nothing special is going to happen. We're not going to see anything. This is just creating an instance of a contact list, and the class is just like, oh, Java's like, okay, I'll do that. But I'm not doing anything yet, right? I'm just making an instance, and then that's it. But this is a visualization of what we have. Contacts, I guess here it's called friend count, but in my class I called it size, whatever. I've got contacts. That's my reference variable. Its type is contact list. And inside of it, so contacts references some contact list. And inside of that, I have a variable called friend count. It's just an integer. But I also have a reference variable to an array of friends, right? That's what we have. But there's no friends there. I've got 5 seats available. But that's what we've got. It's only a visualization of what we have. So, any questions now about what we're looking at? All of these ideas are the same as they were in Python. The only differences are some of the little Javaisms that come up, like the fact that we have arrays and the syntax we used in the class. But the same ideas are still from Python. So, the next 2 things we're going to write, often I usually have these 2, actually, like I write these like last. But I'm going to write them first because they're easy, and I will use them in other methods. I'm going to write 2 methods. One is empty, and the other one is going to be size. Size is the easiest one. If I ever call size, it's basically an accessor for the size field. Tell me how many friends are in my contact list. So just size returns size. Let's write that real quick. Int is the return type, size. Return, size. Again, if you're wondering, why didn't I include this dot size? I could, it's entirely fine, but it's not necessary. This is really only particularly helpful whenever it's resolving ambiguity. Yeah, no, not a question, just a correct, okay. Same with up here, I didn't need the thises in the constructor because there was no ambiguity. It's funny, all of the other classes we've seen in Java so far, the course and the friend, all of the parameters for the constructor would correspond one-to-one to the fields for the class, like first name, last name, email. Course code, department code, course name, right? Those all corresponded to the fields. You'll notice here, there's no such thing. Size and friends are not that related to the fields or the parameters here. I mean, the initial capacity kind of matters for the friend, but yeah, there's no. First of all, they don't need to match. You don't need to have the parameters match the fields, only if you need them to. And yeah, there's no ambiguity. I didn't need the this. So there's size, and then is empty. Public Boolean is empty, return, size equals 0. There. Cool. Remember, this Boolean expression will be evaluated, and whatever it's evaluated to will be what's returned. If calling size returns 0, 0 in fact equals 0, so that's true, it's empty. If size returns anything that's not 0, this will evaluate to false, and the value false gets returned. Yeah? Yeah. Now, you might say, you know, it's interesting that you're actually calling the method size. How do I know this is the method size and not the field size? The parentheses, right? Variables don't have, you know, we don't use the parentheses by them. The functions, methods, we do. So I'm using the method. But I could just as easily do that. And you're absolutely right. It's really not, it's functionally identical. One's really not better than the other. I kind of like this one because size is like how one would interface with the class. And so I kind of like, even if I'm inside, I like to use the public-facing interface. That's really not that important for why. There's a lot of nuanced reason why I think this is better, but at the end of the day, it really isn't. Just FYI, yeah.
It makes sense. Like anytime you're actually going to change the size, you obviously have to like
Deal with the field,
access
yeah.
the field. Otherwise, you just might as well use the method.
So the reason I like to use, I'll try to explain a little bit more in more detail why I prefer to use the method. In this class, there's going to be a bunch of public methods, and there will be at least one private method. Private method meaning it shouldn't be accessed outside the class. And public method, and the fields are private as well. But this class will have public methods, and the public methods are how one interfaces with this class, right? Because that's the public interface, all the public methods that you can call to interact with this class are written in a way that it's safe to interact with because they're public. So because I know they're safe to interact with, let's just use that one, right? You're going to say, yeah, but size just returns size. So does it really matter? And the answer is no, it really doesn't. But still, that's just why I go with calling the method instead. At the end of the day, not a big deal if you don't. So there we go. I added these two methods, and we can go verify that they exist. So let's go sout contacts.size and sout contacts.isEmpty. There. I called these two methods. We just wrote them. When I create a new contact list and there's nothing in it, its size should be 0 and its isEmpty should be true. 0, true. Cool. So far, so good? You might think, okay, these feel like really stupidly easy methods. Yes. Even the more complex ones we're gonna make are not overly crazy. It's just when they're all kind of like packaged together with the collection, it's how we use the collection where like the complexity can come in, where we're solving complex problems with these things. But with good design of our code, we can make all individual bits as simple as they can be. And that's kind of the goal here. We want our code to be simple and easy to understand. So there's those two methods. All right? Add. So here we go, add. All right, so I have an array of size 5. Okay? And right now, if I were to go add a friend, the friends won't be, the order of the friends in the contact list won't matter. They're not going to be sorted alphabetically. The order is going to be arbitrary. The order will depend on the order in which they were added, but the meaning of the order really doesn't, there's no like intrinsic important meaning of the order other than that one came before that one because it was added first. Okay? So when I go and add a friend, which index are we going to put it in the array? 0. Great. And then what's size going to be? 1. Perfect. If I want to add another friend, which index should it go to?
Size
1. What's its size going to be now after you add it? Okay. So you add another one, you add another one. I got 5 friends in there. Size is 5. I go to add another friend. What do? Well, we're out of room. Kind of sucks, right? Arrays have fixed size. But we're going to do a little trick. Here's what we're going to do. What we're going to do is we're going to go, okay, we'll just make, if ever I try to add to an array that's at capacity, I will just automatically make a new array that's bigger, copy the references over from the old array, and then carry on. So if I had 5 friends in my array, and I wanted to add a new one, the answer would be, well, it goes to index 5, right? Because remember, we start at index 0. So the first one's in 0, second 1, fifth is in 4. Sixth should go in the 5th index, index 5. But there's no room. Well, make a new array that's bigger, copy the references over, and then add it to the 6th index, because there is a 6th index now. I'm pointing over there, not at you, but because I've got my screen there. There you go. This is the idea. Any questions about the general idea here? Take a moment, think about it. Yes?
So it's making a deep copy of the data?
No, it's not going to be a deep copy. It's going to be a shallow copy. Can you tell me why it doesn't matter or why it does?
Oh, because we use the reference to access to the data?
Well, there's 2 reasons why we want a shallow copy here. I mean, we could do a deep copy. Raise your hand if you don't know what I mean. If you don't know what we're talking about when we say deep or shallow. Okay, perfect. What you're seeing right there is a shallow copy. A deep copy would make a copy of the array and make a copy of what the reference variables in the array are referencing. Okay? Oh, here. Oh, come on. Shallow copy? Deep copy. Cool? That's the idea. Now, if these included reference variables to things that included reference variables to things that included reference variables, the question is, well, how deep do you go? Now, the reason we actually only care about doing a shallow copy is because first, actually I don't know which one's better to explain first. The initial array is going to become useless, so I'm not going to have reference to it. Like the old array, that was too small. We'll lose reference to it, the garbage collection will come along, and I've no, like those aliases will disappear, so I'm not worried. The second reason is, whenever you have immutable data, data that is immutable, the potential downsides of having aliases are entirely irrelevant. Because I can have a million aliases to that one object. But if I have no way to modify that object, then who cares? The only way it would be an issue if I have a million references to you, and one of those references makes a modification to you, and then everyone else is like, wait up, hold up, something changed, that's weird. But if it's not possible to modify that data, we actually eliminate the concern of having the deep copy, which is even better, right? All the more reason to, immutable is good. We like immutable. It eliminates any potential like pass by value, pass by reference issues. Good question though, or good observation or whatever. Other questions about this? Now you gotta figure, if I have an array of size 5, I can add 5 things. But like the general, normal, for lack of a better term, working function of this method is going to be just add it to the next available spot in the array. But every once in a while, we'll have to like expand the capacity of the array a little bit, right? Only every once in a while. Here, after 5, it'll happen once. If the initial capacity was 100, I can add 100, and then on that 101st one, I gotta make the array bigger. Fine. So it actually doesn't have to happen very often. So what we'll do is we'll write the function as if like, well, this is the normal stuff. But then we'll write another function that'll deal with the special case, and we'll just call that function. Just because I think it's a nice separation there. So, here, everyone close your eyes for a second. I wanna surprise you. I don't know. Yeah, okay. Great, there. Okay, you can open your eyes now. It's funny because there was like 3 people that actually did it, so thank you. So here's your general add, okay? Public Boolean add. It's going to return a Boolean actually, which is interesting. The reason we want to return a Boolean is it'll return true if it added successfully and false otherwise. Now, with the way we're going to implement add, it's not going to be possible to fail, meaning this function will just always return true, which is perhaps a little funny, but this is actually a very common Java interface strategy. Now, I'm writing this in a way where it'll automatically make more room in the array. But it might be the case where my collection, I have a fixed size array, and if I ever try to add more beyond that, I don't want it to automatically expand. I want it to fail. And if in that case, I would say something like return false. But that's not what we're doing here. So this right here is the actual code, the general purpose code for, hold on, let me check something here. Yeah. This is the general purpose code for adding a friend to the contact list. Now, you might find it funny that we're indexing friends based on size, but remember, when I have an empty array, and I want to add when I have an empty array, what value does size have? 0. So if I want to add a friend, which index should it go to? 0. And then size will become 1. So size is now 1. If I add another friend, what index should it go to? 1, which is conveniently the value of size. So because of zero-based indexing, the value of size actually always corresponds to the next available index. Right? Because the first thing is at index 0. You have a question?
Yeah, say you had one that like had a size of 100, but nothing was in it, and then you like filled it up with like say 5 things, and you got rid of the third thing. Is it like how do you know that that's the next available spot?
Well, we're going to have to figure that out. We're going to have to deal with that situation. You're absolutely right. That is a peculiar problem we're going to have to think about. Now, we're going to talk about it when we get to remove. I like where your head's going, right? Because this is going to be an implementation issue we got to deal with. But we'll come up with a way to figure it out. And there's a couple of ways we could figure it out. So this is the general adding a friend. And look at that. That's shockingly simple. That doesn't mean trivial. It doesn't mean necessarily trivial to understand. But look at what this code is doing. You take the friend object already exists, so you get a friend as reference, a reference to a friend as a parameter. You take your friend's array at index size, and you set it equal to that friend. Now here, immediately after, I increment size. Remember, size plus plus means add 1 to size. Great. And then return true because this function has, or this method has to return a Boolean. That's it. That's all that's happening. Adds to the next spot, increment size. That's it. I could keep track of another field called like next available spot, but it would be always the same value as size, so I don't need to do that. Now, you might be looking at this and you're like, well, how come he's actually using the field size here and not the method size that he just talked about, right? And this really comes down to me, it's not that I really cared about the size. I'm laughing because it's like there's some nuance and some method to my madness, and if someone were to go like, yeah, but I really have no argument to argue against you, just this was what my mind did. A sign of a good programmer is if you end up spending way too much time thinking about stupid stuff like this. Where you're like, well, I could call the field, but I could call the method size. Why would I call the method size? Well, I don't know, because I'm not really caring about the value. Like, I don't care about the size. I care about the value of the field size that happens to correspond to the next available spot. So because it's not really the size that I care about, I'm just going to call the field. And if you're like, yeah, but fine, whatever. But I spent time thinking about it, and that was my final conclusion, call the field size. Yeah. I could, but I don't like my code to do more than one thing per line of code. I'll come back to that in a second. Yeah.
So I could have used the method size now.
You could. You could do this, but the method size is like, tell me how many things are in that array, right? Which isn't really the spirit of what that line of code is doing. When I'm justifying this, it's because I was sitting there in my office going, I could call the method size or the field size. Which should I pick? And I had to come up with a reason to pick one over the other. It's not necessarily a good reason, it's just that was my reason. So let's not focus too much on that. It really is somewhat arbitrary. Now, to the question you just asked, or the statement you just made. We could do this. We could do this. I don't like this because I don't like it because I feel that doing this makes my code that much more harder to understand because that line of code is doing more than one thing. I like my lines of code to be simple and straightforward. Now the reason this works is because whenever you have a plus plus next to size, really what it means is run this line of code and the last thing you're going to do after all said and done, increment size. Okay? So this would take the value of size, index friends at that size and assign it to friend, and then actually add 1 to size. Interestingly, you could do this. I mean, this wouldn't work very well. This would actually be bad in this particular situation. But this means before anything, increment the value of size and then run the remainder of that line of code. First of all, don't do this here. This would be bad. If you like it this way, fine, go ahead and do it. I advocate against it because code is not for computers. Byte code is. Compiled code is. Code is for humans. And what am I really saving by saving that one new line character? A byte, right? Like nothing. So it really doesn't matter. You're absolutely right. It's functionally the same, but I like that first line of code adds the reference variable at the specified index. The next line of code increments size. I like it better that way. But you're absolutely correct. Now, this will work just fine until we run out of room. And let's actually do that for the fun of it. We'll go here, contact list, friend A equals a new friend. There. Actually, here, I can just do this. I can say contacts dot add now, and I'm just going to put a new friend directly in that line of code, just like that. Okay, just for simplicity. Does this make sense to everybody, or is anyone like, wait, what? All it is I'm doing more than one thing in this line of code for the sake of just making it quick and dirty. I'm making a new friend object and immediately passing it as the argument to the add method. That's all. Yeah?
So what would the address of the objective will be?
Sorry?
So instead of initializing and saying like new friend, instead of making a friend name of variable, name of object equal to new friend, what would it, like, do we need to initialize the variable?
We don't need to, because I don't actually care about the variable. I'm immediately creating it and passing its value to the reference variable friend in the add method. This is just a quick and dirty way to do it. If I was doing this for like an actual real reason, I would probably give each one a reference variable. Oops.
So I'm saying, is it necessary to really add a reference, or if you do it that way?
Like this?
Yeah.
I can't speak in an in general case because there is really no in general case for this situation. This is I'm just showing you this particular example. If I run this, we've added 5 friends, and it should be fine, right? I've created it. It's got an initial capacity of 5. We run it. Its size should be 5, and its isEmpty should be false. Looks good. Everything's great. But of course, if I go to add one more thing, what do you think we're going to see?
Index out of bounds.
Array index out of bounds. Array index out of bounds. Index 5 is out of bounds for length 5, right? There is no index 5 in a length 5 array. 0 through 4 only. Because we didn't do that trick of expanding capacity automatically. Now, like I was saying before, I could say if isEmpty. So, no, not isEmpty. I don't want isEmpty. I want if size is equal to friend dot size. Is it length? Length. So you can get the length of an array, like the capacity, by asking just its field length. And I'm getting the size. Now, why am I using the method size here? Well, because I actually care about the size this time in terms of what the size really means, right? I'm giving you a window into my psyche right now, right? So what do I do in this situation? It's possible that I just do, basically it returns false to let me know that, like, no, you can't do it. Fine. It's not going to crash. It just returned false, whatever it is, what it is. Yeah? Oh, also you'll notice here, I didn't do anything with the return value of add. I don't need to if I don't really care. So all of these did return a true. They just kind of like went into oblivion and disappeared. So there we go. I could do this, but that's not what I'm going to do here. I'm going to write a method that will automatically expand the capacity of my array. There's no expanding the capacity of an array. It'll be make a new array that's bigger, you copy everything over, and we're happy. I'm just going to copy this. And I'm going to change this. So now, we'll look at expand capacity in one moment. But now, if the size is the capacity of the array, we're just automatically going to magically expand the capacity, update the friends field accordingly, and just carry on as if everything's normal. Because if it expands its capacity, it just adds it to size, right? It's like, oh, add it to index 5, which exists now because we just expanded the capacity. But how does expand capacity work? Well, here you go. First, notice that this is a private method. And the reason it's private is it's an important method for the functionality of the inner workings of this class. But I don't want anyone to just call expand capacity. I don't want to be in main and say contact list.expand capacity. No one should be able to do that. That doesn't make any sense. So it's a function or a method that's important for the inner working of the class, but I don't want it to be public facing. I don't want anyone to interface with that particular method. So what does it do? Well, the first thing it does is it makes a new friend array I called new friends. New friend. And its size is actually just twice the size of the previous array. There's actually some nice mathematical properties as to why we always want to double the size every time, so we double it. And we'll learn more about that soonish. But we always double the size. So if it's 10, it goes to 20. If it's 20, it goes to 40. If it's 40, it goes to 80, and so on. It's always going to double. Computer scientists love 2's and multiples of 2's and powers of 2. And then what do? Well, for I0, oldFriends.length I++, copy the value at oldFriends at index I into newFriends at index I. I only need to loop, newFriends is twice as big as the oldFriends, but I don't need to loop to all the way to the end of oldFriends. Sorry, all the way to the end of newFriends because there's nothing there, right? Like oldFriends only has 5 spots. I only need to look at the original 5 to copy them over to the new one. And then when I'm done, return the new array. Make a new array that's twice as big. Copy everything over that was there originally, and then return a reference to the new array. And that return reference to the new array will be what the friends field just references. So we are changing what the field, the friend field, is referencing. Everything's fine. It's going to work. It's going to be happy like this. So with this code, I can go back here and hit run, and now everything should work just fine. Yeah, 6, false. It's not empty. Great. Any questions about that? All right, awesome. I'll see y'all later.